Okay. Okay, anyhow, if it's not clear, try to wear a headphone. I'll try meanwhile to increase my to rise my voice. Okay, try to use a headphone. Because I'm using a headset actually. Anyhow, I'll raise my voice so you can hear it properly. Not more. Okay. Some of you are saying it's clear, some of you are not very clear. Anyhow, I'll try to raise my voice in order so everyone is going to be able to hear me. Anyhow, today we are going to have an orientation or an induction to the course of Advanced RC Design. Okay, to the course of Advanced RC Design, what we are going to see, what we are going to cover, what will be the handouts, what will be the PowerPoints that we are going to work in, some of the software packages that we are going to try, the assessments. So some general idea about the course of Advanced RC Design. Okay. Okay. So now if you see, the course is called Advanced RC Design, and it has a code of CE 4244. By this time you should know already what's the meaning of CE, what's the meaning of the numbering, because it's important for you as well. Okay, CE, the first CE is representing construction engineering. The second CE is representing civil engineering. Okay, so we are talking about construction engineering, that is the section. And then CE is your civil engineering. 4 is representing the fourth year. The first number is representing the year. So if we talk about CE 4, then it refers to the fourth year. If you refer to a code with CE 2, then it's referring to the second year. Okay, so the first 4 is representing the year. Second number is referring to the number of semester. So we are talking about, normally this course is to be taken in the second semester in the BTech level, although we recommend the students to take it in the first semester, since now mainly a lot of projects are in structural designs only. Okay, and then the other 4 is referring to the number of course in that particular semester. Okay, so we refer about 4.2, 4.4. First 4 is referring to the year, so you are talking, or you are having a course in the fourth year, second semester, and it's the course number 4 in the degree audit. Okay. Now regarding mark distribution, since this is the biggest questions, or this is the biggest question normally the students are having or arising about this semester, we are going to have a different methodology of assessment. We are not going to have any mid-term examination. We are going to have 2 tests. So test number 1 and test number 2. Test number 1 is going to be for in week number 4, and then the other one is going to be in week number 8. Each one of them is going to be for 15 marks, and most probably each and every test is going to be a multiple choice test. Now the other 10 marks is going to be for the assignment. So I'm going to give you the assignment. Most probably I'm going to give you real set of drawings, structural plans, where you will be asked to design that particular building using a software or manual. That's going to be up to you. Okay, you can work in a group or you can work individually. Okay, that's going to be up to the circumstances. So let me decide whether you are going to do it individually or in a group. Okay, so 10 marks for the assignment, which is going to be a structural design of a 2-story building, full design. Test 2 tests for 15 each, and then a pop-up quiz, which is representing attendance. Okay, so now instead of taking the attendance regularly, the department has decided to have a quiz to evaluate your attendance. So instead of the student leaving the PC and going somewhere else, no, we are going to have the quiz at any time in the lecture. So it can be in the first 10 minutes, last 10 minutes, it can be the first half an hour, last half an hour, at any time. So at any time of the lecture. Okay. Now this particular pop-up quiz will be for each and every lecture, and this is going to be 1 or 2 questions maximum. Most probably it's going to be one question only. It can be either in the e-learning, or it can be written in the Teams, and then you will answer it. These questions are solely for the purpose of the attendance, to check who is available at that time and who is not. So the questions are going to be simple questions. They are not going to be complicated. And once again, they are meant to check whether you are attending or not. Okay, and the last 50 marks are going to be for the final examination, which is not clear yet whether we are going to go to have it physical written exam, or is it going to be multiple choice. Till now, most probably whatever the talk is happening, that is going to be a multiple choice exam. But still, till we have a clear picture about it, we'll inform you at that time. Okay, so 50 marks for the internal and 50 marks for the final exam. 2 tests, no mid-exam, and then several be carrying a weightage of 10 marks. Before we continue, am I talking very fast, or are you able to hear me? Are we okay with the with the base? Okay. Okay. So whatever we are going to tackle in this particular lecture. By the way, if you have any question, you can interfere directly. Let us keep this particular course an interactive course, rather than having it to be a very rigid where a lecturer and students are there. So if you have anything to be discussing, you can raise your question, and then I'll try to answer it. Okay. I'll explain. Now, till now, I didn't upload the PDF. I didn't upload the PowerPoint. Mainly, my PDF is going to be around 200 something pages, and that handout was made. For the purpose of having one handout for a reference of structural concrete design. Okay, so that involves a lot of things from design of structures a lot of things from advanced RC design. Okay, so not everything in the PDF you are going to follow, but everything in the PowerPoint you will follow. Okay, PDF is a reference for you, whether you are a graduate, whether you are a student in the college, whether you are a student in the project. That can be considered as a reference because it contains a lot of things. It contains how would you do the positioning of the columns, how would you design a beam, column, foundation, how would you design a combined foundation, I believe, how would you analyze for wind, how would you analyze for seismic. So a lot of points are mentioned in the handout. If we are able to cover these things in the PowerPoint, it will be very good. If not, then the handout will be a reference. So whatever I'll be discussing in the PowerPoint, or whatever it will be discussed, whether it's a PowerPoint or handout, that's going to be included. Otherwise, whatever I didn't include or whatever I didn't explain, it will not come to you. Okay. Now we are going to have a small recap Okay, a small recap of whatever you have taken in the previous semesters, and to check what is the level that we need to go for. Okay. So if I started asking the students, like, why do we use a lot of RC? Why do we use a lot of concrete in our country? I mean, why don't we use any other material? Okay. Once again, keep it interactive so you will understand. You can write comments in your chat box. Why do we have a lot of concrete structures? Why don't we go for steel? Why don't we go for timber, like any other country who's doing the timber as well? Any idea? A good structural engineer is not the engineer who will do your calculation for you. Okay. A good structural engineer is the person who can decide what to be used, when to be used. Okay. So different answers were there: suitable to stand heat, because it's available and cheap, elasticity, cost and weather maybe. Okay, because of the many advantages of concrete. Okay, stability and stiffness. Okay. Now, normally, on the nature of the country. Okay. Normally we have 4 major materials that we construct our buildings from. Okay. So we have four materials that normally we construct our buildings from. First is timber. Second is concrete. Third is steel or structural steel. Fourth is glass. Okay. So we have 4 structural elements or structural materials can be used. Okay. So we have, once again, we have timber, we have concrete, we have steel, and we have glass. Okay. Now, taking one by one, if we think about one by one. Now, when we talk about, for example, when we talk about glass, some countries started already to have slabs made of glass, beams which are made of glass, which we are calling as panel and fin. Okay, so certain buildings are fully made of structural glass, which is not suitable to our country, since it will not provide you with the privacy that you require. Okay, although for the structural glass, for certain type of structural glass, they can give you a better strength than the concrete itself. Okay, so the main idea why we are not using glass, because glass is not offering the privacy that we require in our country. Okay. The second thing, when we talk about timber, we have a big issue in terms of moisture due to the humidity and moisture available in the air. Timber is not going to be a good solution. Okay, timber is not going to be a good solution. It's a good solution for areas where moist is not a big issue, or areas where natural disasters used to happen. Like, for example, if you go to the US, they are using a lot of wood structures, and the main reason that they have a lot of natural disasters. So instead of building a concrete and then it will be lost because of the expenses of the concrete, then it's better to go for a wood, which is a bit cheaper than concrete. Okay, so we ended up talking about concrete and steel, and these are the two structural materials we talk. And when we talk about steel, we don't refer to steel bars. Okay, steel bars are called to be bars. When we talk about structural materials, we talk about concrete, and we talk about structural steel, where you have studied in design of structures too, where we are referring to the I section, X section, C, and whatever. Okay, we are not talking about bars anymore. Okay. So when it comes to a direct comparison, between steel and concrete, can you tell me why would we prefer concrete? So some of you already have illustrated some good answers. You have referred that it has a high fire resistance, and then elasticity. Elasticity is for both of them actually, although for steel is a bit better. Cost, okay, weather, widely available, heat, workability. Okay. So normally when it comes to design, okay, when it comes to design, there are two main things. Okay, there are two main things. One is the ability to withstand heat or fire, and the other one is whether it can withstand moisture. Okay, two things which are there mainly. Okay, we have one, in our country we are having a lot of moisture in the air. Another thing is fire. We need to protect our element in case of any fire. Okay, so two things are there. We need to critically analyze the concrete and steel for. Now, if we see the origin, okay, of the materials, okay. Now, concrete is made of gravel, sand, cement, water. These are materials which are not affected. By water. Now, once again, we talked about moisture and we talked about fire. Two things. Okay. So once again, when we talk about gravel, sand, cement, these are not affected mainly by water, so they will not have a huge effect on concrete. So concrete will be good in terms of if it has been exposed to water. Now, the opposite way around when it comes to steel. Now, steel is a material. We know that if it has been exposed to water, you will see a lot of rust is happening. Okay. Okay. So a lot of rust is going to happen. And in case of fire, once again, if we return back to the origin, we see that the steel was made of minerals which were liquid. Okay. They were heated and then they were cooled. So if you reverse the idea of applying heat or fire, you will see that your structural steel is going to melt into a liquid once again. Okay. So when it comes to fire, steel is not good because the origin of the steel is not able to withstand fire. While when we talk about the concrete, the origin or the materials, the raw materials of the concrete, which are the gravel, sand, cement, these are not easily affected by fire. Yes, after a certain time they will be affected, but these are not directly affected by fire. Okay. Plus the other thing that Afaf has talked about, which is availability. When we talk about the raw materials, concrete raw materials are available in Oman a lot, so it is a bit cheap compared to the other methods or the other structural materials as well. Okay. So when we go and see our slide, we can see that concrete, we have said, concrete is very durable. When we talk about durability, we refer to the fact that it can withstand whatever is happening in the air. So durability is mainly related to water. Okay. That's why if you remember when we talk about the cover, if you remember previously, we used to talk about cover for the elements in your design. We used to have a cover for fire. We used to have cover for durability. Okay. And durability is referring here more into the moist and the water. Okay? That's why it was referring whether it's going to be um, mild, moderate, severe, very severe. And if you read the details, what they mean, these mild, moderate, severe, very severe, they refer to water. Okay, and then the other thing is fire resistance, as whatever we have said. Plus, concrete can be molded in whatever shape we want it to be. So if you see here, um, this is what you call wave barriers. Here, road barriers, and we can see that this is concrete used in regular frames. Okay. So concrete can be shaped as long as you have the form for the concrete. Concrete can be shaped at any shape that you want it to be. Okay. So this is the third advantage of the concrete. Are we okay till now? Is it clear? Yeah, corrosion or rust. Okay. Rust is another term for corrosion. Okay. Are we clear till now? Are we fine? Okay. So the second step, where we are talking about the different. Okay. The second step is where we are talking about the different RC components. What are the different, what you call, components? Uh, so when we talk about steel, and concrete, the direct comparison between them to know how we are going to have the combined action of the RC. And once again, when we refer to RC, we refer to reinforced concrete. So we refer to concrete and steel bars. Okay. Now, before deciding which to go with which, and concrete will go in which zone, steel will go with which zone, we need to start analyzing first, knowing the properties of each and every element. So now, when we talk about concrete, now can anybody tell me why concrete is good? Why concrete is good in compression? You used to know that concrete is very good for compression, steel is very good for tension. Why is that happening? Now, instead of memorizing, you should be understanding the fact why this is happening. So why concrete is good for compression? Why? Which one is strong and takes high load? Do you refer to steel or do you refer to concrete? Because of the material used, exactly. So because of the material, what is happening? Now, once again, if you understand how the elements behave, you will understand why compression is happening here, why tension is happening here, or why this is good for compression, why this is good for tension. Because elasticity of steel, so steel is good in tension. So steel is it good in? Okay, steel is good for compression. It's not good for compression. Okay. Now let us try to illustrate that. No. Okay. Okay. Now, are you able to see this whiteboard? Are you able to see this whiteboard? Okay. Now see, in order for me, okay, okay. Now in order for me to explain this is easily, I need to return back once again to the origin of the material. Okay. So assuming that I have a concrete tube and I have a steel bar, a steel bar. Now we have said here we used to have different materials inside. We used to have soil, we used to have cement, gravel, and water, right? And when it comes to steel, it used to be mineral liquid that was heated and then being cooled. Now, if you go and see here, okay, if you take a small portion zoomed at any portion of your concrete tube, you will see that we have a gravel, and then we have another gravel, okay, and between these two gravel there is, let's say, okay, there is the sand trying to fill the gaps. The main duty of the sand is to fill the gaps, right? Okay. And then what do we have? We have the binding material, that is cement and water, trying to join these elements together. Okay. So this is the zoomed section, what is happening inside. Okay. So we have gravel filling the place, and then after that, for the small places, we have the sand. After that, the binding material will come to bind these two elements together. Now, if you see, if we apply, if we start applying compression, okay, if we start applying compression, what will happen? You will see that the gap between the two elements is going to reduce. Okay? The gap between this element, this gap is going to reduce. And whenever it's reduced, it makes the element to be stronger. Because whenever we have gaps, it means that the element is weaker, right? Okay. So whenever we apply compression, you will see that the particles are entering inside each other, okay, or trying to compress each other to reduce the voids which are available. Now, if we do the opposite way around, if we try to apply tension, now the weakest point available in this particular joint or in this particular zone section is not the gravel, is not the other gravel. The weakest point is available in this particular location. Okay, it's like I have one pen and another pen glued together. If you compress them together, okay, nothing will happen, because they are trying to, okay, we are trying to refer to the, squeezing the gap which is available. Now, in the opposite hand, or on the other hand, if we try to pull these from each other, you will see that the weakest point is the gluing part, okay, which is the weakest point. So what will happen? Eventually later, you will see that your concrete particle has been separated from the other, the gravel particle has been separated from the other gravel particle. Okay. Now, when we talk about steel, eventually steel, instead of acting like two materials joined together by a binder of concrete, it's like two elements, two gravels have been what you call glued together by a binder. The steel is not the case. Steel is acting. If you see a steel bar, you will not find certain gaps between them. So steel bar is more into a single element action rather than two entities or two elements glued together. Okay. Now, when you take this particular thing, when you take this steel bar, you will not find one weaker part and one stronger part. Okay, it's one element only. Okay, so that's why when it comes to tension, you will not have an issue. If I have this pen, I try to pull it, there is no weaker points and stronger points anymore. Okay. Now, when it comes to tension, we say that's good because there are no gaps for the steel bar. Now, when it comes to compression, why we used to say concrete is good for compression and steel is good in tension? Now, it does not mean steel is not good in compression. Okay. It does not mean steel is good in compression, but it means that there is a certain slight problem with concrete in tension, okay, or in compression, sorry. Okay, and that's referring to the size or height of element. Okay, so if we talk about, let's say that I have a bar which is so long, and I have another bar that is very short. Okay, if we start applying a compression for the short one, what will happen? And for the long one, what will happen? Now you will see for the short one, normally nothing will happen. Okay, because it's already too short. You cannot what you call, you cannot squeeze it easily, or you cannot compress it easily. Okay. What about the longer element? The longer element. You will see that the longer element is going to what you call buckle in one side. It's going to buckle either on the right side or on the left side. Are you okay? Okay. Now a good example is stick. You know, العصا. العصا. إذا تشوفوا العصا too, if I go and handle any stick, you will see the longer one, easily it will buckle in one side. Why? Why it will buckle? إذا عندي عصا, if I have a stick, why would it buckle? Because of the length? Or something else? So is it only length? Cross section. Okay, we are referring rather than saying length. Okay, rather than saying length, we should say cylinderness. Cylinderness. Okay, where we are referring. You have studied cylinderness in design of structures too, and you should know what's the meaning of cylinderness. Where we are talking about the ratio of length to one of the cross-section dimensions. Okay, length to width or length to height of the section. Okay, and I'll give you an example. Let's say that I have two sticks. Okay, or two wood. Okay. One is a stick, طولها meter, of 1 meter length, and then the other one I have what you call the square wood that is used in construction, اللي هو خشب المربع, whatever we call it, the square. Do you know it? Both of them are of 1 meter height. Which one is going to buckle? A stick and then the square wood. You will see that the stick is going to buckle while the other one is not going to buckle. So the reason is not only about the height, although the height is similar. No, it's going to be about the cross section as well. Okay, so two things. So we are talking about the height and we are talking about the cross section. Are we okay? So if you are facing from this fundamental, if you are facing a long column that you feel that it will fail in buckling, then the best option is going to increase your cross section. By increasing the cross section, you will avoid buckling from happening. Are we okay? Are we fine? Okay. 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 Um, why do we call this to be buckling? Why not bending? Once again, today is only a recap. So I need to cross-check that you understood the fundamentals before going to the other major parts. If you understood the fundamental things, the other things are very easy. Designing a building or whatever. As long as you have the good fundamentals in structural engineering, you shouldn't have an issue. Why do we call this to be buckling, not bending? What is the reason? Why do we have it to be for beam only bending? Bending is static. No. Buckling is vertical. Not necessary. Okay, the closest answer till now is Asma's answer. Okay, where we are talking about the direction of loading. Okay, although it's not a full answer. Okay, now I'll just try to illustrate it for you. Let's assume that we have a column. So this is my column, and on the other hand, I have a beam. Okay, let's just let me delete this. Make it just straight. Okay. Okay. So I have one column and I have one beam. Apologies for my drawing because I'm trying to adapt with whatever is available. So we have a column and we have a beam. Normally we have minor and major. Okay. We have major and minor axes. Now if you see the beam, this is my major axis, which is along the beam. So this is going to be your major, and this is going to be your minor. Okay, so we have major and minor axes. Major, minor axes. Now, when we go to the column, it is going to be shifted. So we have the major column, our major axis here, and we have the minor axis here. Are we okay? Now, if you see the beam, how the beam is loaded, you will see that the beam is loaded in this way. Where my loads are perpendicular to the major axis. Okay, where they are perpendicular to major axis. Are we okay? Are we fine? Okay. So here, failure is mainly going to happen due to bending. The element is going to bend. Okay. While in the other scenario, for the column, we have the load coming on the line or parallel to the line. Okay, it's not coming perpendicular. Okay, it does not have 90 degrees with the major axis. Okay, so mainly it's going to be on the line of the major axis or parallel to that. Okay, now the failure here is bending, so it bends directly. So we need to protect it from bending. Okay, and then for this one, before it buckles, first it will try to reduce in size, right? Are we fine? Okay. So first what will happen here? First compression is going to happen. And then it will start buckling. Even if you see the stick, first it will try to go down, and then later on it will buckle. So the first failure here is called compression, and then the second failure is called buckling. Okay. Now, to define what's the difference between bending and buckling, it's related to how load is acting on the major axis. So if the load is perpendicular to the major axis, we call it as bending. Okay. And if it's parallel or in the same line of the major axis, we call it as compression. Okay. This element, we call it as flexural element. Have you heard of flexural previously? I think you have taken flexural stresses, mechanics of material or applied mechanics or something. Flexural stresses. Okay. So this is flexural element, and flexural is referring to bending. Okay. Flexural is another name for bending. So we call it bending stresses, or we call it as flexural stresses. Okay. And these are elements which are controlled by bending. We are designing them for bending. Okay. And these elements, we call them as axial elements. Sorry. So we have axial elements and we have flexural elements. If your load is perpendicular to your major axis, we call it as a flexural element. If your load mainly is coming to be on the same line or parallel, we call it as axial element. So a good example of flexural element is a beam, where you see that the load is acting perpendicular to the major axis of the beam. So we call it as a flexural element, or a member which will be designed for moment. Okay. The other example is slab, and once again you will see that you are putting all the loads perpendicular to the major axis. The other minor axis is the thickness, which is small. The longer side is the major axis, whether it's length or width. So once again, your load is perpendicular to the major axis, which will cause you to bend. Whether it's one way or two way, we'll talk about it. Okay. Now, a column is a good example of axial element, where you will see that it's a vertical element, and then the load is coming to be perpendicular or the same line. I mean, not perpendicular, sorry, on the same line or parallel to the major axis. Okay. Another good example is wall, and once again, wall is loaded vertically normally, where the major axis is on the vertical side as well, unless we talk about earthquake, where another load, earthquake or seismic, where another load is going to come from the horizontal as well. Okay. Is it clear now what's the difference between flexural and axial? Are we okay? Okay. So let us go and see here. Now you will see that we have discussed almost everything here. We said strength when it comes to tension. We said concrete deals as two separate materials, or two separate, it's not materials, but just to make it a bit easier for you. So two separate entities glued together. That's why if we try to pull these two particles away from each other, they will break because of the weak point in the gluing part. While in steel, it acts like one material, where if we try to tension or to try to apply tension, nothing will happen because it acts as one element. In compression, it's the opposite, or it's the other way around. So for compression, when it comes to concrete, these are the two particles, and we are trying to push them together. So the gap which is between them is going to reduce, and whenever the gap is going to reduce, it means that the element is going to get stronger, because less gaps, less air. For the steel, once again in compression it's good, but we said if we are having cylinder bars, then these cylinder bars are going to buckle. So it's not long bars, but cylinder bars are going to buckle. Now for durability, we said concrete is, the raw materials of concrete are good in terms of resisting the water. We are keeping our concrete outside. We are keeping the concrete in the water actually for curing. Okay, so it does not have any issue in terms of living with moisture. Okay. The same thing for the fire. If we go and see the raw materials of concrete, they are gravel, cement, sand. They are not affected by fire up to a certain limit. Okay, up to a certain limit. After a certain limit, they'll be affected. Okay, especially the cement and sand. Now, when it comes to steel, we said if water is coming to the steel, it will corrode or it will have rust. So it corrodes if unprotected. And in terms of fire resistance, it's poor. Why it's poor? Because we have said, okay, we have said that the origin of the steel, that it was a liquid, heated, and then cooled. So if you reverse the action, you will see that your steel is going to melt. Okay. Now, let me just check any questions. Okay. Okay. Now the part where we need to discuss is the strength in terms of shear. Okay. Why this is good and why this is not good. Now why concrete is good, or why concrete is not that good for shear, and why steel is good for shear? What do you think? Once again, keep it to be interactive so you will learn. Any person? I said we discussed tension, compression, durability, fire resistance. How would you solve how would you describe shear? For shear, concrete, it says for you to be fair or average, steel is going to be good. Why is it so? Any idea? Okay. I said for shear, when we talk about shear, it says for you concrete is not that good, steel is good. Okay. Once again, related to single material. Okay. This is only an illustration. So there are what you call, there are minerals, different minerals are available, but they act as a single material. Maybe steel is not good. Now, what's the meaning before proceeding? What's the meaning of shear? What's the meaning of shear? What's the meaning of shear? What do we mean by shear first? Return back to the origin so you'll understand. What's the meaning of shear? What's the meaning of shear? Cutting. How cutting is happening? Deformation happens when a perpendicular load is active. Okay. So normally we refer to shear whenever there are two side forces. Okay, two side forces. So let us say, okay, let us say that there is one force here, and then there is another force here, and we have another force here, and we have another force here. Okay. Whether we are referring to the load and self weight, or we are referring, okay, or we are referring to different loading. One is up and then down. But regular case, we are loading and self weight. Self weight is going down. Loading is for the elements trying to sit in its position, and then the weight and the load is going down. Now, what will happen here? You see the situation. Okay, which one is going to be easier to cut? In the drawing that I have drawn for you, which one is easier to cut, and why? Now, can you tell me where is the weak point here in the steel, and where is the weak point in this arrangement? Okay, you will see that in steel, it's a coherent material. Okay? It's a coherent material where no gaps are appearing. It means that it's hard for you to cut it. Are we okay? Now, it's easy to cut wherever there is a weak point. And you will see that here in concrete, the weaker point is available at the joint. Okay, so you will see that if you try to apply a large shear force, concrete is not going to be strong because of the binding area. Okay. While when we talk about steel, it's good because we don't have weak points like whatever we have in the concrete. Are we okay? Is it clear? Are we fine? So everything is simple if you try to let it be simple. Do not complicate the thing. Okay. So we referred and we explained. If you see, we explained tension, compression, shear, durability, and fire resistance. Okay. Now I'll give you two questions. Okay, I'll give you two questions. Now, question number one: how would I protect? There are already buildings which are made of steel. Now, the long skyscrapers, اللي هن الناطحات السحاب. Okay, these skyscrapers are mainly built of steel, not concrete. How would you solve the issue of the fire resistance? Once again, for concrete, normally we can extend to a certain time. After that, we are going to go for steel. Okay, coating other than coating. Coating, painting other than painting. Fireproof or painting. Okay. Other than painting. Other than painting. Other than painting. Other than coating. I know coating and painting are the same. Yes. No. Whatever steel is used is going to be affected by fire. So how would you solve the issue? One is coating. Okay, one is coating or painting. I do agree, but we don't use it a lot. That's not the common practice. Now, if you go to most of the malls, most of the commercial buildings as well, they are not using painting. You will not see the steel columns, right? normally. If you go to the malls and everything, most of them are built with steel sections. Okay. So the most accurate answer is whatever Afaf has answered, is where we are going to cover the steel section with the concrete. Okay, where we call it as an encased section. Okay, we call it as encased section, where the steel is going to be covered by a concrete section. Are we okay? Okay. Coating is not called coat by concrete. Coating is for mainly for paints rather than what you call, rather than encasing it. Okay, encasing, we refer to, it's like, for example, I have an eye section. I have an eye section. An eye section column. Okay, so what we need to do, we need to place a concrete column. So a concrete column will be here. Or to be accurate, keeping a certain coverage here, where additional reinforcement will be there as well. Okay, this is whatever we call it as encased column, where we have a steel. Okay, where we have a steel section covered by concrete. Okay, so this is the practical method. This is the practical method which is used in practice. Okay, I'm not sure about the electric energy, but whatever is used in practice is coating for small things only. And whenever we talk about large things, we talk about encasing. Okay. Now the second question: do you remember the 9/11 situation? 9/11 situation. Okay. Where the towers? You remember برج التجارة أو برج التجارة العالمي? Okay. Now, if you see the situation, where we are talking about, assuming that this is a tower, okay, and then a big aeroplane is coming, hitting it from the side. What is the regular failure shape? How this should behave? Will it will it fall in the side, or will it fall vertically as it failed? So this is the tower, and this is the plane. Now I'm talking about if you have a large horizontal force and this is your element, what will happen? You will see that your element is going to sway, right? I'm not talking about the what happened over there. I'm talking about what will happen if the damage was caused because of the aeroplane, right? Like whatever I have drawn. But the situation, what happened in reality, that the tower has fallen vertically rather than going to the side. What was the reason? Okay, so instead of taking a lot of time here, so the main reason why the towers has failed is because of fire. Okay. The aeroplane hit the tower, it didn't fail, but because of the huge fire caused by the damage, the columns, whatever steel columns which were available, they melted, and that's why the whole roofs were dumped above each other. Okay, so actually the failure, if you go and read about it, the failure has not happened because of the airplane, the direct effect of the airplane, but it happened because of the fire caused by the airplane. Okay, because they have used steel sections, and they were painted, and this is the problem with the painting. Painted sections need to be regularly checked. If any portion is not painted, then fire can go directly to that point. Are you okay? It was painted. As far as I know, it was painted rather than encased. And once again, painting should be regularly done. And you make sure that each and every point in the column is covered. Okay. Are we okay for this point? Shall we go for the other point? Are we okay? Okay. So once again, structural engineering is very easy. It's not complicated. The only thing you need to try to imagine, okay, rather than complicating the situation, try to imagine something closer to you so you will understand it. Like when we talk about compression and tension, we are referring to one pen or two pens with the glue. Okay. Now going for structural components. Now if you can see, we have the typical structural components where we talk about slabs, beams, columns, and foundation or footing. I think everyone knows these basic structural components. So slabs, horizontal elements, beams, horizontal elements as well, vertical elements, which is a column, and then a footing. Now, what you need to know in this level is a little bit more than that, because these are not the only elements that we are using in reality. Okay. So we have the first element, which is a staircase. Okay, a staircase. So in your project, you will be required to go and design a staircase as well. Okay. Staircase is eventually a slab. Okay. Staircase eventually is going to be a slab, and it's designed to be a slab. And for example, let's say that we are talking about this particular stair, where here it's supported by a beam. You can see that the beam is here, and this portion is supported by a slab. Okay, supported by a slab. So if we go and see that we have, let's say, okay, we have here a landing, and then we have here another. So this is, let's say, this is the staircase. Okay, where you are talking that this is a landing, and this is the stair slab. Now for you, actually it does not matter whether this is an inclined element or a vertical element. In your representation of free body diagram, this can be transferred to be this way, where some loading is happening here, another loading is here, another loading is here. We are talking about the steps, weight, and we are talking about the tiles as well. Okay. So this is my idealization of the problem. Okay. So if you can analyze this one, then this is going to be the same as analyzing that one. Are we fine? Okay. So it's very important for you to know how to idealize elements, and we are going to talk about this particular thing in the upcoming lecture, how we do idealization. Okay. The second one is whatever we call it as RC wall or shear wall. Okay. So we have regular walls, regular blocks. These are not having any structural impact. If we go and remove all the blocks, in your houses, for example, if you go and remove them, unless they are meant to take some loads, but normally blocks are not meant to take any load. So if you remove your wall, which is made of blocks, then nothing is going to happen to your structure. The blocks or the wall that we have in our homes is meant only for the purpose of privacy. When we talk about shear wall, we refer to a structural wall that is made of concrete and steel, that is a reinforced concrete, okay, which is going to help for the purposes of making my structure to be stable. So, for example, if I have, let's say, so let's say that I have this particular paper. Okay, I have this particular paper. This is representing my my structure now. This structure is able to take vertical loads without an issue, but because it has been designed to. Now, if we apply any horizontal load, you will see that these elements are mainly not designed to take horizontal effect. Okay. So how the shear wall is acting? The shear wall is trying to make your structure to be a little bit heavy. If your structure is a little bit heavy and you try to apply any horizontal load, you will see that it's harder to move it. So for example, if I bring my phone here, which is acting as an extra weight representing the shear wall. Once again, the shear wall is so heavy, it's so big, so it will make the weight of the structure to be huge. If we try to apply now horizontal load, you will see that it's hard to move my structure. That's why when you go and see those buildings that have been designed for earthquake and wind, you will see that we are going to have lifts. Okay. Any structure that is above 3-story, normally we have a lift. We don't have only stairs. And there is not only a purpose just to transfer vertically from one floor to another floor, but the main purpose is to go and have some rigidity in terms of the movement in the horizontal direction. Lift is mainly made of RC walls. These RC walls will make your structure to be heavy. If it's heavy, then it's going to be hard for you to sway when it comes to horizontal and vertical. To horizontal, whether they are wind or they are seismic. Now, if you can see in this particular example, we have different vertical elements. We have different vertical elements. Now you can see this is acting to be my column. Okay. Now if you see here, this is acting to be my shear wall, a single shear wall. Now let's take this one. This is acting as more than shear wall. Okay, acting more than one shear wall connected together. Can you see that? Okay, so we have column, a shear wall, more than one shear wall combined together, or a shear wall combined with other small portions as well. Whatever we call these things, we call them as a core wall. Okay, these are called to be core wall. This is called to be a shear wall, and this is called to be your regular column. Okay. Are you okay? Are you following me? Okay. Okay, so we have a core wall. We have a shear wall. Can you turn off the mic, please? Can you turn your mic, please?
أنا مسكر عليه النت كامل. شو تحب هذا؟
Can you turn off your mic? Okay. Anyhow, so we have core wall, we have shear wall, and we have columns. Okay, and we said whenever we combine shear walls together, we call it as a core wall. And a very good example of core wall is going to be your left. Okay, it's going to be our left. And if you go and see here, we have different, we'll end up with this slide. Okay, we have different structures. Okay, there is a good arrangement for low, medium, and high. Now, of course, we didn't talk about high here. Since in Oman we don't have high-rise buildings. We have either low buildings or low-rise and medium-rise buildings. Okay. So in case you are talking about a single story, for example, in case if you are talking about a single story, then the general arrangement of having beams and columns, whatever we call it as a solid slab, is going to be more than sufficient. Okay. For a single story, second story, and third story, single, double stories, and then 3 stories, then the fact of solid wall or solid slab is going to be sufficient. Solid slab is whenever we are having beams and slabs to be supported by beams. Okay. Now, another system that can be used is going to be a flat slab. Okay. Another system that can be used is flat slab, where it's going to be a little bit cheaper for certain long spans. Okay. So solid slab for regular cases, if we are extending the columns away from each other, we are going to go for the fact of flat slab, and you will understand. We'll go throughout the slabs and we'll discuss. Solid slabs is wherever we are talking about slabs supported by beams. If your slabs are supported by beams, we call them as solid slabs. If they are supported by columns, we call them as a flat slab. Okay. Now, when we go more than 3 stories, we don't we don't go for solid slabs separately or flat slabs separately normally. We go for a combination of flat slab or flat slab with a core wall. Are we okay? So once again, for a low-rise building, whenever we are talking about 3 stories and less, most of 3 stories building or lesser, they don't have they don't have a lift normally. If we go more than that, municipality will not allow you to construct more than 3 stories without a lift. And once again, the purpose is not only the ease of transfer vertically, but to make sure that you will have a good constraint in terms of the movement. Since the core or the shear wall are heavy elements, which will make the weight of your building to be a little bit heavy. And if it's heavy, it's going to be a little bit harder. It's like a chair, you know. If I have an empty chair, I can go and apply a force, and then I'll move it from its position. But if somebody is sitting above the chair, he is causing an extra weight, it's going to be a little bit harder for me to go and move it. Okay. And we are going to learn how to differentiate between solid slabs, flat slabs further. That is whatever we are going to cover in this particular lecture. In the upcoming lecture, we are going to learn the different drawings. What is the meaning of architectural drawing? What's the meaning of a structural drawing? What's the meaning of a plan? What's the meaning of section, structural plan? All of these terminologies, you need to know them. How to do the positioning of the columns. If you have a new project, positioning of the columns, nobody will do them except you. And once again, you need to understand and read the drawings. One of the biggest issues that the industry keeps saying that we are facing, or they are facing from our students, is that they cannot read the drawings properly. So we are going to try to highlight that. I'm going to try to even give you real drawings in which we are trying to go and like this one. We are going to try to do the column positioning and the other things. Okay. Now we have finished for this particular lecture. In the upcoming lecture, we are not going to go for 1.5 hours straightforward. I think that's too much for you. So whatever we are going to go, we are going to go for maybe half an hour, and then 5 minutes break, and then another half an hour, 5 minutes break, and then the remaining lecture. Okay? Any question that you have before we proceed or before we complete the session? Okay, so once again, next class you are going to learn to read the drawings, to develop your drawings. After developing your drawings, you will be able to change the drawing and idealize them in terms of a structure, in terms of an idealized structure, where you can start analyzing. For me, I cannot start analyzing this, or I cannot analyze a 3D. I need to analyze it, or I need to idealize it first. Okay, so a slab, which is a 3D in reality, to be idealized into a 2D member. The same. This is a water tank, so how to idealize it? Truss. This is a 3D truss, how to idealize it into a 2D. Okay, and then later on, we'll learn how to idealize and put the support system, how to put the loading, and then the different types of loading, different type of analysis. So the first thing, you should be able to know the drawings. After that, start idealizing, shifting them from 3D to 2D. After that, understanding the concept of loads in reality. Nobody in reality is going to tell you that this is a point load, or this is the UDL, or this is a uniformly variable. Okay. The issue which is faced by the student, that they have got everything ready in their classes. The loads are set for them. The nature of the load is set for them. And when it comes to reality, they don't know from where they will get this particular loads. So we're going to understand them after doing the analysis of. Okay, after knowing the loads, we'll learn how to do the analysis, basic analysis, which is manual, and I'll show you some of the softwares or software packages where we can do easy analysis without consuming a lot of time in the upcoming lecture, and then maybe we'll go for the design as well. Okay, the recording will be there. I have started the recording, and hopefully you will see it over there. Anyhow, thank you very much, and we'll meet up next session. If you have any comment, if you have any advice that needs to be taken into account for the upcoming lecture, you just either text me in the Teams or you just write it in the comments. Thank you very much.